Okay, what about when t is even? So you see, we're looking at the second term, the fourth term, and the sixth term. Okay, so when n is 2, your term is 4. When n is 4, it's 16. When n is 6, it's 36. Okay, so you can easily see that this is an n square. Okay, but if you want to use sequence A to obtain sequence B, you realize for the second term, you are taking 5 minus 1 to get 4. And then for the fourth term, you're taking 17 minus 1 to get 16. For the sixth term, you're taking 37 minus 1 to get 36. So basically, you're taking sequence A and you're minusing away 1, subtracting away 1 to get your sequence B. This is for the even terms. Okay, so nth term for even numbers is just n squared. Okay, good. We're done with that question. Now question 5. The nth term of a sequence is given by this. So this is the reverse kind of question where they tell you what is the formula, the general term, and then they ask you a few questions based on that. Okay, so write down the first 4 terms. That means when n is 1, what is the first term? You sub in n is 1, you will get 2 times 1, which is 2, minus 3, plus 5. So answer is 4. The first term is 4. Okay, do the same for the next few terms. So you keep subbing in, sub, you will get 7 for T2. T3, you sub in n equals to 3, you will get 14, right? 2 times 9 minus 9 plus 5, so that's 14. And T4 will be 2 times 4 square minus 3 times 4 plus 5, which is 25. Okay, for B part 1, they say another 4 terms of another sequence are 1, 4, 11, 22. Compare this sequence with the initial one. So the first one was 4, 7, 14, 25. But the second one is 1, 4, 11, 22. So for every term in the second sequence, it's just the first sequence, the term in the first sequence minus 3. Okay, so 4 minus 3 is 1, 7 minus 3 is 4, 14 minus 3 is 11, 25 minus 3 is 22. So what you have to do, you just take the formula given in the question, which is 2n squared minus 3n plus 5 for the first sequence, and you minus away 3 to get the nth term of the second sequence. Answer is 2n squared minus 3n plus 2. That's it. Okay, part C. Hence find the 385th term. So 385th term, you sub in over here, right? Minus 3 times 385 plus 2. Okay, so you sub, you will get 295,297. That's the answer for part C. Okay, so these are all standard questions. Question 6. Consider the following number patterns. 1 square minus 1 is 0, 2 square minus 2 is 2, 3 square minus 3 is 6, 4 square minus 4 is 12, 5 square minus 5 is 20. So find the next line. It will be 6 square minus 6 to give you 30. This is the sixth line, right? First line is 1 square minus 1 equals to 0. So the sixth line will be 6 square minus 6 equals to 30. Hence the eighth line will be 8 square minus 8 to give you 56. And the nth line will be n square minus n. Okay, you can further factorize this to n times n minus 1 because n is a common factor. So this can be factorized to n times n minus 1 in bracket. Okay, use the pattern to find 139 square minus 139. So 139 square minus 139, if I were to apply this n times n minus 1 over here, right, it will just be 139 times 139 minus 1. which is 139 multiplied by 138. And the answer is 19182. Okay, and the last part is the positive integer value of x such that x squared minus x equals to 2450. So x squared minus x equals to 2450, right? If I factorize out x, I will get x times x minus 1, 2450. So what number and that number minus 1 when multiplied together will give me 2450. Okay, a simple trial and error in your mind will tell you that 50 times 49 is 2450, right? Therefore, x must be equals to 50. Very good. Okay, next, question 7. Cat made a series of diagrams using dots and lines. First 3 figures are shown. So, in this case, there are 2 patterns to be observed. One is the number of dots, and one is the number of small right-angled triangles. Okay, so there are 2 things that we are observing. So, let's look at the table. For figure number 1, the number of dots is 4. The number of small right-angled triangles is 2. Because we have one here, and then we have one here. Okay, for figure number 2, the number of dots is 1, 2, 3, 4, 5, 6, 7, 8, 9. And the number of small right-angled triangles is 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have 8. And we count the same for figure 3. We have 16 dots and 18 small right-angled triangles. Okay, so what is the pattern that we see? For the number of dots, I think it's pretty straightforward that they are all perfect squares. You see 4, 9, 16, 121 and so on, right? So 4 is just 2 square, 9 is 3 square, 16 is 4 square, 121 is 11 square. So for 19, if your figure number is 19, right, what should be the number of dots? You see, the number that's being squared here, right, is 1 more than the figure number. So for example, when the figure number is 3, number of dots is 4 squared. When figure number is 10, number of dots is 11 squared. So when figure number is 19, number of dots will be 20 squared, which is 400. Okay. Now let's go to the number of small right-angled triangles. So for figure number 1, number of small right-angled triangles is 2. For figure number 2, number of small right-angled triangles is 8. For figure number 3, number of small right-angled triangles is 18. So if we try to find a pattern, this is like 1 times 2, this is 2 times 4, this is 3 times 6, and for figure 4, it will be, oh, I didn't write down here, figure 4, number of dots is 25, which is 5 squared. Okay, for figure 4, what will it be? It will be 4 times 8, right? Because these numbers are like 1, 2, 3, 4, and the second number is 2, 4, 6, 8, 10, 12, whatever. So this would be 32. How about for figure number 10? So you see, the number here and the number here are the same, right? When figure number is 3, the first number is 3. When figure number is 2, first number is 2. And then the second number over here is just 2 times of the highlighted number here. So for example, if it's figure number 10, right, the number here will be a 10. And the second number would be a 20 because it's 2 times of 10. So number of small right-angled triangles will be 200. Same thing for figure number 19. You will have 19 times 38. So that brings you to 722 small right-angled triangles. And therefore, for figure number n, it will be n times 2n, which will give you 2n squared. Okay, for this one, figure number n, number of dots will be n plus 1 whole thing square. Correct? As we found just now, 4 plus 1, 5 square will give you number of dots. 3 plus 1, 4 square will give you 16 number of dots. Okay, so we already completed the table, and let's write down a formula. So x in terms of n, right? X is equals to n plus 1 square, and y is equal to 2n squared. So just by drawing a simple table, you can find these two easily. Okay, next question. You have 1 cube equals to 1, 2 cube equals to 3 plus 5, 3 cube equals to 7 plus 9 plus 11. So you see these are all the odd numbers, right? And the number of numbers they are adding is equal to the number here. So when the number is 2, you have 2 numbers being added. The number is 3, you have the next 3 odd numbers being added, and so on and so forth. Okay, so for part A, the fourth pattern, right, will be 4 cube. 4 cube will be equal to the next 4 odd numbers. 13 plus 15 plus 17 plus 19 equals to, oh, that's all. Okay, that's all the pattern they want. And then 5 cube will be equal to the next 5 numbers, which are odd, being added together. So 21 plus 23 plus 25 plus 27 plus 29. Okay. Now B part 1. Write an expression for A, the first term in the sequence for n cube. Okay, in terms of n. So basically they're asking for, let's say when n is 1, right? The first term was 1. Okay, when n was 2, first term was 3. When n was 3, first term was 7. So they want you to find a pattern for this 1, 3, 7, 13, 21, etc, etc. Okay, so since there's no common difference, right? 1, 3, 7, 13, 21, there is no common difference. Let us try to draw a simple table. Okay, so n refers to the term number and A refers to the first term. Okay, so when n was 1, your A first term was 1. When n was 2, first term was 3. When n was 3, first term was 7. When n was 4, first term was 13. When n was 5, first term was 21. So what do you observe? What's the relationship between this 1 and 1, 2 and 3, 3 and 7, 4 and 13, 5 and 21? Okay, do you see that this one, if let's say you take 1 and multiply by the previous number, which is 0, and you add 1, you will get 1. Okay, for n equals to 2, if you take 2, multiply by the previous number, which is 1, and you add 1, you will get 3. This 3, multiply by the previous number, and you add 1, you will get 6 plus 1, 7. Same thing, 4 times 3 plus 1, you will get 12 plus 1, 13. And 5 times 4 plus 1, you will get 21. So do you see that every term, right, that you get, like 21, how do you get 21? You will take the term number itself, multiply by the previous number, so 5 times 4, and then you add 1 to that. Okay, so what does this mean? This basically means that A is equals to n times n minus 1 plus 1. Okay, so when n is 4, for example, 4 times 4 minus 1, you get 4 times 3, 12, 12 plus 1, 13. That's how you get the term itself. So you expand this using a rainbow, you will get n square minus n plus 1. This is your B part 1. Okay,